we are going to talk about resolution of a vector. So what does it mean by revolution? So first of all, let's talk about a few theory points, then we will um, go in more detail about it. So the process of splitting a vector of the process of splitting a into vector in wait vector into two or more vectors is called resolution of a vector. So this is the definition, and this might be confusing right now, but so let's literally talk about every single point that we have in this topic, then I will explain it once at a time. So the splitted the splitted, I'm not sure if that's the spelling, but I hope it is. The splitted parts are called are called the components are called the components of the given vector of the given vector. And the final point that we are going to discuss is it is just opposite process of addition or composition addition or composition of vectors. Okay, so let's just talk about what we are talking about. So let's say I have a vector. So first of all, let's start with the definition. The process of splitting a vector into two or more vectors is called resolution of vector. So what does that mean? So let's say I have a vector. Okay, so this is going to be my vector. Let's make it white, so make it stand out. So this is my vector. So this is the original vector, right? And I'm going to make it small so that I can do multiple copies of it. So if I want to resolute this vector, there might be various things that I can do. For example, I can take this vector and I'm going to show three different ways. Obviously, there are infinitely more possible ways. So I'm just showing three. I might even show more if I want to. So let's take this vector. I'm going to take this vector and I'm going to resolute this into two vectors. How am I going to do that is because I'm going to do it. So we have this vector, right? And we will try to use the parallelogram law. So I'm going to do this, copy that, move it. Okay, not that. So let's I'm trying to think of a way to show you this. So let's do this. I'm making it now, so just wait a minute, and after I make it, it will be much more clear. So let's take these two, let's make it dotted, and let's make it not arrows, and let's make it a lot more thinner, and let's change the color of this to blue and this to green. So as you can see, this original vector has been changed into this two vector. So this original vector has been changed to this two vector. So this vector is the resultant of these two vectors. So this will be the resultant, right? So in this case, so that's we are talking about. That's what we are talking about when we're talking about splitting. So this is one type of splitting, right? And there is obviously much more or much many ways to do this, and we do this because this is useful. So another way you can do this is by I'm going to take these vectors by making the components, so the components at 90 degrees. So I'm going to show that one because we know that the x-axis and the y-axis are at perpendicular to each other, so they're at 90 degrees. So this might be a useful property when you're doing this. So that's why this might be useful. So let me copy this, copy that, and let's make both of them orange, dotted lines, smaller and smaller. Okay, so we have the first method where we just made a random angle. So this angle right over here, let's use gray. So this angle random, this is a random angle, whereas you can also do resolution by this way, where this is 90 degrees, and this might be useful because you might say this is the x-axis and this is the y-axis, so you can take it down to the components. So that will be very useful, and we will do this, and we will learn about rectangular resolution much more than these other ways. And also the third way I want to show you is, we did it with, we are only doing this with 2 vectors, and a question that you might have is, can I do it with more vectors? And the answer is yes, you can do it with as many vectors as you want. The thing is that it might not be useful to have different many vectors than 2, sometimes many vectors than 3, so it depends on the case. So it just depends on you and what do you need. So vector resolution is done because it's a very useful feature that we have, and it helps us, in many ways that you will see in questions. So it just simplifies the question, which is why we use vector resolution. So let's see, so these are the 3 ways there, and in this case, so this can be thought as the resultant, right? If we were just checking out this green or blue vector, or this green, blue and purple vector, the R would be the resultant, and that's pretty clear. And also these vectors right now here, they don't have to be in like this way at all. They can be in random direction as well, as long as the resultant leads to this vector. So that's also something that I want to clear up. And there can be as many vector as you want, and any angle in any shape, as long as their resultant is the vector itself. So I think that's clear. Now let's go back and look at the second part. The splitted parts are called the components of the vectors. So the splitted parts, so this part and this part is splitted, this part and this part is splitted. The dotted lines are not the splitted part, and so these lines will be called components. So let me show, let's do it by way. So this thing, this thing, this thing, this thing, this thing, this thing, this thing are the components, and I think that makes sense, since they, so if you have a toy, the components of the toy are the things that make the toy. That's why it's called a component. So in the same way, the components of these vectors, so the components combined form the vector that you originally had. That's why it's called the components. You can think of it like that. And the third one, which is, it is just opposite process of addition or composition of vector. So let's go back here. If you were in doing addition or composition, you would say that the blue vector and the green vector gives a resultant, which is the white vector. But in this case, we are taking the white vector and we are splitting it into the green and blue vector, right? And a fact or a cool thing that you can think about is, when you're doing addition or composition of vectors, addition or composition, you have some vectors. It might be 2, it might be 3. You have some number of vectors, and you have only one resultant. You are sure of the resultant you're gonna get. Whereas now you have the vector, and the components can be different. So the components do not have to be the same. You are not limited with that. But the resultant by the components must be the vector that you have. So I think that's pretty clear. And so I think this is gonna be it for today's video. In the next video, we're going to talk about rectangular resolution of a vector, and it's a very useful feature that you should know if you want to work with vectors, since it really helps you out. So until then, bye bye.